Hello, let us look at some questions from the last exam. So here comes the first one. Let sine A be 3 over 5, and then we want to get sine of 4A. So we know that here, uh, sine of A is equal to 3 over 5, 3 over 5, but to get sine of 4A, we can consider sine of 4A as a sine of 2 of the 2A. Then using the double angle formula, you can say that this is equal to 2 sine of 2A, and then cosine of 2A. Now, but if I have to rewrite it, sine of 2A is equal to 2 times 2 sine of A and cosine of A. And cosine of 2A becomes 1 minus 2 sine square of A. Now, then here we have sine of A takes care of everything except cosine of A. When sine of A is equal to 3 over 5, what do you realize about cosine of A? Many of you guys can easily see that it must be 4 over 5, or you can actually draw the triangle. This must be A. Since sine is 3 over 5, then by Pythagorean theorem, the other side must be 4, and that should get you cosine of A is 4 over 5. Then all I have to do now is to plug in all the values. 2 times 2 becomes 4. Sine of A, which is 3 over 5. Cosine of A, that's 4 over 5. 1 minus 2 times sine of A was 3 over 5 square. And let me try to calculate this one first here. We get 3 over 5 squared becomes 9 over 25. Now, that 9 over 25 is multiplied by 2. So we get 18 over 25. But when that is subtracted from 1, then we get 7 over 25. So we get here, this one becomes 12 times 4 becomes 48 over 25 times 7 over 25. And the denominator becomes 625. And then here, when you multiply 48 times 7, so here we get 6, 5, and 28. So we get 33. So 336 over 625. All right. So now then let's look at the next question. We want to prove that tangent of 3x is equal to this one. So one way which we can do is we can rewrite this one as tangent of 2x plus x. Then this now becomes tangent of 2x minus tangent of x divided by 1 plus, or actually plus, and this one is minus. Oops. One minus tangent of 2x times tangent of x. But what do you know about tangent of 2x? Tangent of 2x in this case is equal to tangent of x times 2 over 1 minus tangent square of x. So then I'm going to put this one in both of the tangent of 2x places. then we would have gotten 2 tangent of x over 1 minus tangent square of x plus tangent of x, entire thing divided by 1 minus, or tangent, or 2 tangent of x over 1 minus tangent square of x times tangent of x. So now we have a complex fraction. So if I multiply top and bottom by the common denominator, which is 1 minus tangent square of x here, then we would have gotten, so this one cancels out with the denominator, so we have here we have 2 tangent of x, but tangent of x is multiplied to this one, then we get plus tangent of x, but tangent of x times negative, that's so we get negative tangent cube of x. Now, on the denominator, so this factor multiplied to 1, so here we get 1 minus tangent square of x, and this cancels out with the bottom one, so and then minus 2 tangent square of x. So when I now combine the like terms, then we end up getting 3 tangent of x minus tangent cube of x, and I can combine these two terms, so we get 1 minus 3 tangent square of x. That becomes our final answer. Alright, let's look at number 3. In this case, I mean, we can do many different things, but one of the easy way to do is just, I can expand cosine of sum and difference of the angles of the cosine. Then sum of the angle for cosine is cosine of A times cosine of B minus sine of A sine of B. Now difference of the angle becomes plus cosine of A cosine of B, and then plus sine of A sine of B. And you can easily see that these two cancels out because positive and negative. When you combine this term and this term, we get 2 times cosine of A cosine of B. And 1/2 and 2 cancels each other out. We are left with cosine of A times cosine of B. And that's exactly what we wanted to prove. Alright, let's look at number 4 here. Sine of A is 2/3 and then in quadrant 2. Cosine of B is in quadrant 1. Then what is this? So sine of A minus B is sine of A times cosine of B minus cosine of A and then sine of B. Now, then notice we have the values for the first two terms, so I can write it as 2/3 multiplied by 3/5. But what is cosine of A? So from here, if I have to draw the triangle, sine of A is 2/3, so we get 2/3, and this will be the A. Then by Pythagorean theorem, you know that the adjacent side would be square root of 5. But the thing is, cosine of A would have been equal to negative radical 5/3 because it's on the second quadrant, cosine is negative. How about sine? Since cosine is 3/5, using the same strategy, we can say that sine of B would have been 4/5. But since it's in quadrant 1, we don't have to worry about positive or negative. So these two becomes positive, so our final answer becomes here 6 over 25 plus 4 radical 5 over 25. Then our final answer becomes 6 plus 4 radical 5 over 25. That becomes our answer. Alright, let's look at number 5. So here, sine of 3x plus sine of x over this portion I can write down sum to product formula. Then sine of 3x plus sine of x becomes 2 sine of 3x plus x over 2 and cosine of 3x minus x over 2 all over 2 cosine of x equals to 1. That's how I can write it up. Now on my left side, I know that becomes, and these two cancels out, sine of 2x times cosine of x over cosine of x. Then these two cancels out as well. Then we get to see that sine of 2x has to be equal to 1. Now, then what do I realize? For what angle is sine equal to 1? Then 2x must be equal to 90 degrees. That tells us that x must be equal to 45 degrees. Now, let's look at angle theta as BOA. So that would have been theta. Then from here, what is AB? AB would be the tangent. So AB would have been my answer for this one. Now, then if this is tangent, what is the hypotenuse in this case? Yes, that would be the secant. Because tangent squared plus 1 equals secant squared. So OB would have been secant. Likewise, angle alpha DOA, that would be angle alpha. Now, tangent normally would have been this way, but instead of that we have this horizontal line. That's in fact cotangent. So we can write down CD over here. But what is paired with cotangent? It'll be cosecant. So OD would have been cosecant here. All right. Show that sine of 75 is equal to this one. So we can rewrite this one as sine of 30 degrees plus 45 degrees. Then that's equal to sine of 30 degrees times cosine of 45 degrees. Oops. And then plus cosine of 30 degrees and then sine of 45 degrees. Then we get to see that sine of 30 is 1/2. Cosine of 45 is radical 2 over 2. Plus cosine of 30 becomes radical 3 over 2. And then lastly, sine of radical 2 over 2. Then when I combine them together, I get radical 2 over 4 plus radical 6 over 4. Then when I combine them together, since we have same denominator, radical 2 plus radical 6 over 4. That becomes our final answer. How about number 8? When you square this one, we get sine square of A plus 2 sine A cosine of A plus cosine square A is equal to 1/3. I just expanded it the left side. But when I combine these two things together, that's equal to 1 plus. But what is 2 sine A cosine A? In fact, that is sine of 2A is equal to 1/3. So when I subtract 1 from each side, then you get sine of 2A must be equal to negative 2/3. And that becomes our answer. Now let's look at number 9. How can I rewrite this one? All right, wait a minute. What is sine of A times cosine of A? Imagine if I had 2, then that would have been sine of 20 by the double angle formula for sine. But I can simply multiply by 2, so I have to divide by 2 as well. Then my numerator from here to here becomes sine of 20 degrees cosine of 20, because that was from there, and cosine of 40 degrees and cosine of 80 degrees. Divide the whole thing by 2 because of the denominator here. So if I multiply top and bottom by 2 one more time, then I can see that this portion becomes sine of 40 by the double angle formula. So you get sine of 40 degrees times cosine of 40 degrees and cosine of 80 degrees. Here we get that's it, over 4. Then of course I'm going to multiply by 2 and 2 one more time. Then this portion becomes sine of 80. So we get sine of 80 and cosine of 80 over 8 so far. Then here I can multiply top and bottom by 2 once again. Then we get sine of 160 by doubling the angle 80, and then divide by 16. So this would have been our answer, or anything that's equivalent to this one would have been our answer. All right, let's look at number 10. So we have negative A in all throughout, and in order for me to simplify this one, you get to see that sine of negative A plus cosine of negative A, in fact, is equal to negative sine of A plus cosine of A, because sine is an odd function and then cosine is an even function. So now I'm going to square this one. How about here? Negative sign goes out, so we get plus sine of A, and then this one is, since the even function, we end up getting cosine of A. And then tangent of A, tangent is a odd function, so we get negative tangent of A as well. Here this becomes sine square A minus 2 sine A cosine of A plus cosine square plus sine of A cosine of A. I'm just copying that down. And we get negative tangent of A. Now, of course, these two becomes 1. And then negative 2 sine A cosine A plus that becomes minus sine of A cosine of A. And then multiply that by a negative tangent of A. Then we simply end up getting negative tangent of A. And then plus, when I multiply all three things together, we get plus sine of A cosine of A, and then tangent of A is sine over cosine. So we get cosine cancels out. So we get tangent, negative tangent of A plus sine square A. And that would have been the simplest answer. All right, so then I'm going to stop here, and I'll see you later. Bye-bye.